So I want to start with the explanation of the algorithm behind this project using flowchart so that you can all understand what is this all about. And so we start the program, then we read equivalent carbon dioxide and total volatile organic compound values from the SGP30 sensor, then we read the raw voltage from the soil moisture sensor, then we convert the raw values of the soil moisture to the moisture percentage because it provides a more intuitive and meaningful representation of soil moisture, and people tend to understand values of percentage in a more friendly manner than just raw voltage values, so that's why. Then we save the current ECO2, TVOC, and soil moisture values in arrays for analysis. Then we update the real-time animated plot in MATLAB. Then in the command window, we'll see the output of the sensor readings of ECO2, TVOC, and soil moisture. Then we check if we have more than one recording of soil moisture data. Then we display the correlation matrix for the soil moisture of ECO2 and TVOC. If not, then we go back to start. Then, if yes, we'll check if we have more than 10 recordings of ECO2 data. Then we classify air quality into clusters using k-means and visualize clusters in a scatter plot. Then we check if we have more than 10 recordings of soil moisture data. Then we use soil moisture and TVOC data to predict ECO2 levels via linear regression and display the regression model details and make predictions for new inputs. If no, then we go back to start. Then we check if ECO2 levels exceed 1000 ppm. If yes, we get the alert that we have high ECO2 levels. Then we check if soil moisture is less than 20%. If yes, we get the alert that soil moisture is critically low. If no, we check if the soil moisture is more than 80%. If yes, we get the alert that soil moisture is too high. Then we pause for 1 second after the iteration, and the program only finishes when it is manually terminated. So I've already explained in the flowchart that I used loops and conditional statements, but here is how it looks in the MATLAB. So I used while loop to update the graphs in real time. Then I used if statement to check if there are enough data points. Then I used if statements to check if we need any alert messages. As for the functions, I used the function to convert the raw value of the soil moisture data to the percentage. Now, so that I can show you the graphs, let's run the program right away. Now you can see the first graph, and let me exhale the air onto the ECO2 TVOC sensor so that you can see the change of values. So you can see the values of ECO2 and TVOC increased right away after I started exhaling because there is increase in ECO2 and TVOC. And here you can see the second graph, clustering of air quality data. So you can see those that are like less than 1000 ppm are like blue. It means that they're good for health, that they're not threatening our health. And those that are of different colors, like light blue or yellow, those are like dangerous for our health. Now let's run the program one more time so that you can see the messages that you're gonna get in the command window. And I'll start exhaling the air one more time so that you can see all the changes in the command window too. So you see the messages that you're getting here while the graphs keep changing, that soil moisture is critically low. Moisture is critically low because I basically hold the sensor in the dry air. That's why we get those messages. And we keep getting predicted ECO2 levels, you see, based on the historical data that was accumulated in the databases. So predicted ECO2 levels are predicted based on the TVOC and soil moisture levels. So hardware setup here is pretty straightforward. We have the Grove Beginner Kit Arduino connected through the USB cable to the laptop. Then we have two sensors connected to the Arduino board. One is ECO2 TVOC sensor, and the second sensor is soil moisture sensor. Both are connected through power supplies to the Arduino board. And then if you want to experiment with higher moisture levels, you can also use the potted plant and water it and put the moisture sensor inside it.